Kia ora, here's the next question from assignment 5. This one's a level 3 question on solving a cubic. So this is a merit question. This one was quite inefficiently done by a lot of you, so that's why I'm YouTubing it. Some of you forgot about the existence of the conjugate root theorem, which is going to make your life far, far happier when you're doing complex numbers problems. So we're given an equation. One solution of the equation, blah, 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 is z equals -2 minus I, and we're told that b is a real number. So what does that mean we can say? Well, we can say this. Since the coefficients are real, it's the conjugate root theorem. Hope you like the pen, guys. It's the sparkly, multicolored thing. The conjugate root theorem tells us that the conjugate z equals z bar equals -2 plus I is also a root or solution. So the easiest thing to do here is to say, well, we're going to end up with this cubic being made up of 3 factors, 1, 2, and 3. And all we've got left to find now is the real factor. But there are easy ways to do the next bit, and there are messy ways. My favourite way to do the next part is this. We can say that z minus -2 minus I times z minus -2 plus I is a factor. And we can pretty easily write that like this. Z plus 2 plus I times z plus 2 minus I. And that equals z plus 2 squared, right? So it's this times this. I've got a difference of 2 squares, right? Minus I squared. So that gives me z squared plus 4z plus 4 minus -1 plus 1 is a factor. So we can write z cubed minus 2z squared plus bz minus 30 as z squared plus 4z plus 5. And now it's very easy to spot what to put in here. It's got to be z take away 6. Be careful, we've still got to go back and get b, but we can say that the roots are z equals -2, -2 plus I, -2 minus I, and 6. So how do we get b quickly? Well, we just have to partially expand. So matching coefficients, we've got bz is equal to, well, there's not going to be anything z-y coming out of z squared. So we're going to have -24z plus 5z. So bz is equal to -19z. And that gives us b is equal to -19. Now there are other ways to go here. Some of you who didn't spot the conjugate root theorem did quite well by just substituting that root in here and working it through, but it felt like a lot more work. So have a look at that and see if you like that method.